Okay, for these ones, we're going to match the ordered pair that works for the following equations. These take a little bit of time, so just try to be patient and work them all out. First of all, in an ordered pair, the first number is the x value, and the second number is the y value. So to solve these, you're simply going to substitute in the 4 for the y value and the 3 where you see the x value. I hope that makes sense. Okay, so we're going to put our 4 here. And then this means 2 times 3 plus 3. Well, 2 times 3 is 6, and 6 plus 3 is 9. And so I know this one's not going to work because 4 does not equal 9. So that one doesn't work. So let's sub in the second value. Okay, so we're going to have x and y. So the 2 will go in where the y is. And the -1 will substitute in where the x is. And now I'm going to solve. 2 times -1 is -2, and -2 plus 3 is 1. Does 2 equal 1? No. So that one doesn't work. Okay, moving on. I'm going to sub in the next one, the x and the y. I put a 0 in for x and a 3 in for y. So 3 equals 2 times 0, plus 3. This one's going to work because 2 times 0 is 0, and 0 plus 3 is 3. So 3 equals 3. Yay, we found one. Okay, so this ordered pair works for this equation. So you would continue this pattern of work for each equation. Okay, so I'm going to start from the beginning. And I'm going to start with the 3 and 4. So it's 2. I'm going to put the x value in for x. The 3 goes here. And then plus the y value. And we're going to see if we get 10. Ooh, and we do. Because 2 times 3 is 6. And 6 plus 4 is 10. So we found it. 10 equals 10. Okay, so this equation, 3/4, works for our second one. Oh, a lot of work here. Okay, moving on. X and Y. So let's start. We already know this one's done and this one's done. Okay, so a -1 and a 2. So the Y value is 2. So 2 equals -1 minus 1. -1 minus 1 is -2. 2 does not equal -2. So that one does not work. Okay, so let's try this one. We're going to substitute -6 in for y and -5 in for x. This one will work. -5 minus 1 is -6. -6 equals -6. This one works. So this equation goes right here, which means this equation, let me change colors here. This equation is probably going to work down here. Let's prove it. 4 times -1 plus 5 times 2 equals 6. Okay, 4 times -1 is -4 plus 10. Does that equal 6? -4 plus 10? Yes, 6 equals 6. Okay, so we've matched them all up. For question 2, what is the slope of each line? Our first line is a vertical line, and we learned that a vertical line is undefined. The second line looks like it's increasing as we read it from left to right. If the line is increasing, we say it is positive. The third line, if we read it from left to right, is decreasing. If it's decreasing, we say it's negative. And a horizontal line, flat line straight across, has no slope. We say it's zero slope. For question 3, we are to look at the graph and describe the situation, and then write an equation that represents the situation. So our first thing to do is look at the title. It's gasoline usage. And it looks like the more miles we drive, the gallons that are in the tank tend to decrease. So looking like it begins with 15 gallons, and then we drive a bunch of miles, and the gallons of gas decrease. So we're going to describe that situation first. So we write a little statement there about the situation. Now we have to write the equation. Now remember, when we write an equation, we use y equals mx plus b. And we first want to determine, where does the graph begin? What is the y-intercept? And this graph begins at 15. Then we're going to look at the rate, or the slope, of the graph. I do see that our slope is negative because the line is decreasing. So now I want to find good points and count the rise over the run. So I'm going to go here and here are 2 good points, and then I make that slope triangle. It rises 1 and runs 25. I can see each block is skip counting by 25. So our equation is y equals negative 1 over 25x plus 15. So what this means is it begins with 15 gallons in the gas tank, and it decreases 1 gallon of gas every 25 miles that's driven. Find the slope of each line. Which graph is the steepest, and how can you determine this? Well, first of all, I'm looking at all 4 lines, and they are all increasing, so they're all positive. I do know that. Now, to find the slope of a line from a graph, we make a slope triangle. First, find really good points. So I'm going to look at the first one, and I can see it looks like right here is a good point. And then the next good point appears to be right there. If I continue going down the line, maybe here to here. Okay, so now once I've identified my good points, then I make the slope triangle between 2 consecutive points. So we rise and run. I'm going to go right up top here, and I'm going to go rise and run. So this one, 1, 2, 3, 4, 5, it rises 5 and runs 1. So line A, the slope is 5 over 1, which is also just 5. Okay, that seems pretty steep though, looking at the line. Okay, let's go on to graph B. First, find good points. Okay, so I'm going to select here, and here, and here, here. Okay, that's enough. Now I'm going to make my slope triangle between 2 consecutive points. Rise and run. 1, 2, 3, 4. It rises 4. And it runs 2. Okay, which would simplify 4 divided by 2 is 2. Okay, now I'm going to go on to C. Okay, find my good points. Looks like it's going through the origin. Maybe every point is a good point. Yeah. Okay, so this one is going to be up 1 over 1. So let me do that again. It's going to go up 1 over 1. So this one is 1 over 1, which is the same thing as just 1. And then the last one, find my good points. Again, it's a little fuzzy, but just try to do the best you can. Okay, there's some good points. Okay, now we're going to make our triangle between 2 consecutive points, rise and run. It rises 1 and runs 2, so a half. Okay, now I can easily see which is the steepest, because the steepest would have the largest slope. 5 is the biggest number. So how can I determine this? We would say A is the steepest because it has the largest or the greatest slope. Okay, so go ahead and write a statement there on how we determined that. Okay, for our next question, we are going to compare a table, an equation, and a graph. And it looks like we have to figure out who has the cheapest cupcakes. Okay, so we have Sarah. She has Sarah's Heavenly Cupcake, so we can look at the price in the table. We have Kara, Creative Cupcakes, and we just have the equation there. And then Ken's Krispy Kremes, we're going to look at the graph. So let's find how much it costs for each cupcake. So at Sarah's, it tells us right here. One cupcake is $1.50. So that one is pretty easy. On Kara's, the equation tells us each cupcake would be $2 because the rate is 2. And then if I use the graph, it looks like 2 cupcakes is $5. So it's 2 cupcakes for $5. So 1 cupcake, well, would just be half of that. So what's half of $5? So it'd be 1 cupcake for $2.50. Okay, so which has the cheapest cupcake? Well, it looks like here $1.50. That's Sarah. And it's $1.50. The next cheapest one is Kara. And Kara is $2 because that was the rate of Kara's. And then Ken is charging for 1 cupcake, it's $2.50. Okay, so you can get the same information whether it's a table, an equation, or a graph. It's all the same information. Okay, so to answer so how do you determine it? You look for, I'd like to find the price for 1 cupcake, and that helped me see it very clearly. Moving on to number 6, it says a truck is shipping jugs of drinking water and cases of paper towels. A jug of drinking water weighs 40 pounds and a case of paper towels weighs 16 pounds. A truck can carry 2,000 pounds all together. So let's complete this table and we'll show 3 ways that the truck could be packed with jugs of water and cases of paper towels. So I was thinking to put a couple reminders here. The jugs of water are 40 pounds. So if I have 1 jug, it's 40 pounds. If I have 2 jugs, it's 80 pounds. So whatever number of jugs of water I have, I'm going to multiply that by 40. And that's for the drinking water. The cases of paper towels weigh 16 pounds. So 1 case is 16 pounds. So however many cases I have, I'm going to multiply that by 16. And then remember, the key here is that the truck can only hold 2,000 pounds all together. So if I had 10 jugs of water, 10 times 40 would be 400 pounds. Now, keeping in mind we can only have 2,000 pounds all together, I would have to do 2,000 minus 400 to see how much weight is left. And that ends up being 1,600. Now, 1 case of paper towels weighs 16 pounds, so I'd have to divide this by 16. So 1,600 divided by 16, that gives me 100. So now let's just check the weight of that. 100 times 16 pounds each would be 1,600. So now I just need to make sure that 400 and 1,600 totals 2,000, which it does. Okay, so if I had 10 jugs of drinking water and 100 cases of paper towels, that's a combination that would meet the requirement. next we're going to look at it backwards. So now we have 50 cases of paper towels. Remember, each case weighs 16 pounds. So let's figure out how much weight that is first. So 50 times 16, well, 100 times 16 is 1,600, so this is half as much. So this will be 800 pounds. So now I take my 2,000 pounds, subtract the 800 pounds, and I'm left with 1,200 pounds. Now, how much water could fit? How many 40 pounds fit into 1,200? So I would divide that by 40. So 1,200 divided by 40, that's 30 jugs of drinking water. So let me just double check that. 30 times 40, yes, that's 1,200. So now, does that total 2,000 pounds? Yes, 1,200 and 800 is 2,000 pounds. So this is another combination that would meet the requirement. And now we have blank slots there, so we can create our own example. Well, I already have 10 and 30, and over here I have 100 and I have 50. So why don't I just go, I'll split the difference. I'll go right in between there. So let's try 20 jugs of drinking water. Okay, so I'm gonna do 20 jugs, so 20, and they're 40 pounds each. All right, so that is 800. Okay, so now I need to do 2,000, subtract 800, which, oh, we kind of did a similar one the other way. Okay, so that's 1,200. So now how many 16-pound packs of paper towels fit into 1,200? So I divide that by 16. So 1,200 divided by 16, that gives me 75. Okay, which, kind of makes sense because I went right in between the 10 and in between the 10 and the 30, and I got 20, and right in between 100 and 50 is 75. Okay, so now I'm going to do 75 times 16 just to double check the weight, and I'm sure a trucking company would do this. They don't want to exceed their weight limits. 75 times 16 is 1,200. All right, so now let's check our totals. So 800 and 1,200 would be that 2,000 pounds. So that would be the combination of 20 jugs of water and 75 cases of paper towels. Okay, so we have to write an equation relating to the number of jugs of water and the number of cases of paper towels that the truck can carry. Well, we know our total is 2,000. Okay, so drinking water, it has the letter W here, and it looks like a letter T right there. Okay, so I had to do 40 times the water, so 40W. And then I had to do all together. I had to add that together. The paper towels were 16 and the T. So next it says to graph the solutions to our equations. So we're going to put this data, these ordered pairs, onto our graph. Okay, so our W value, right here it says W. Okay, so our W values go down here. So that is our water. So label that water. And our water is going by tens, so we can label this in increments of 10. 10, 20, 30, 40, 50, and that's enough because I actually just need 10, 20, and 30. And then on the T side, right here, the T side, we have our paper towels. So we'll label that paper towels. And our paper towels, we have 100, we have 50, and we have 75. So to go from a 50 to a 75, that's going to skip count by 25. So let's go up by 25s. All right, next we would plot our ordered pairs. So my first ordered pair is 10 waters and 100 paper towels. So over 10, up 100, put a point. The next one was 30 and 50 for our combination. So 30 waters and 50 paper towels. And then we did 20 waters and 75. And our graph looks like it's a negative slope. It's decreasing. And then we would just draw a line through those 3 ordered pairs that we have to show how the graph is a negative slope. Now there isn't anything on the last page, so perhaps in class your teacher will have you do a few more practice problems here.